For years, the pitch was AI will handle it. Bigger context windows, smarter reasoning, and longer chains of thought are what AI labs are pushing for. And AI CEOs keep telling you any month now, the AI will understand your business, run workflow, draft contracts, and be that yellow brick road to no more lazy human employees. In the case of this Gemini 3 hackathon, judges had thousands of entries to look at. Somehow, they handed the 3 prizes to the teams that had stopped believing the pitch. The grand prize is won by accepting that AI shouldn't make the final call. The second place won by forcing AI to think out loud so we can verify the logic. And the third place won by accepting that the AI shouldn't pretend to know what's been lost in the memory. While the CEOs have spent years telling us that AI will replace human workers, and many are actually convinced, none of the awarded products would have received the prize if that were true. I have studied all 3 winning products, and I'll walk you through each point of the workarounds they built to compensate for what AI failed to achieve. What's more important is that I will also teach you how to read any AI pitch backward. So you will also have my ability to see through AI bullshit. Oh, by the way, if you see the hype button on your mobile phone, they look like this. Please hype this video so you can help others to also see beyond the AI hypes. Let's get into it. First up is the human-in-the-loop problem that the industry keeps trying to design around. Human-in-the-loop. Translation: AI can't be trusted. Globot is built for the moment for any supply chain manager that has to make a $1 million rerouting call with maybe a geopolitical or natural crisis breaking in real time. This product starts with 4 agents pulling information from each crucial source to help make supply chain decisions. It started by pulls geopolitical signals from Reuters and Bloomberg, calculates the financial impact, redraw the shipping route, and check whether the reroute will change the insurance status. And finally runs a 5th agent whose only job is to find holes in what the other 4 just concluded. After the check, the system then hands over for human action. This 5th agent and the human interventions are actually both part of the product, and the key point I'm going to discuss here with you. You've probably heard a variant of this architecture before. For example, Anthropic baked it into the training as constitutional AI, i.e. one model writes, a second model marks its homework against a written rulebook. Some others call them critics or judges. Whatever the label is, the design is the same. Because even after the judge, you still need a layer of humans to make the final call, because unfortunately, this exponentially more expensive multi-agent setup plus the judge still cannot be trusted to make the right call confidently. Basically, the judge can still BS its way out. No matter how many checks layers there are, it just cannot be trusted to make a X million dollars decision on its own. The whole human-in-the-loop phrase is the load-bearing wall for this architecture, though the label really makes it sound like some kind of a brilliant, all-inclusive, and be kind to humans gesture. Ironically, the cheapest and the final fix of this kind of a LLM downside is still human approval gate. No, and it doesn't just stop here, because if you dig deeper, you realize this creates one thing that none of these AI lab CEOs expected to see: jobs. Someone now builds and safeguards the agents, experts to verify the agent output, and someone else needs to sit at the end of this pipeline reviewing high-stakes AI outputs, and repeat. So you aren't saving the cost of getting rid of human labors at all. The next demo is about forcing AI to reveal its thinking. Explainable AI. Translation: a black box is still a black box. The demo for Aegis opens with a volume problem. When a natural disaster occurs, the regional 911 system is most likely overwhelmed. You'd have tens of thousands of distress signals from calls, SMS, tweets, or drone feeds within a matter of minutes. There are mainly 2 design pillars in this demo. First, it has a total of 5 agents. The coordinator routes raw signals, triage assigns priority, surveillance analyze income drone imagery, and logistic calculates the routes for rescue missions, and reporters writes the post-mission summary. A very similar multi-agent scaffolding to the one that we just saw in Globot. It's there for the same reason, because a single model just can't hold a complex task like this from end to end. Also, worth pointing out, this is the moment you finally respect how incredible the human brain is in handling such a complex task. Second, the explainable AI. Early users couldn't act on AI's priority scoring because AI's recommendations are black boxed. So they couldn't see why one casualty had been ranked above the other. The same black box problem that have actually killed many of the enterprise AI pilots. The fix was to force every agent to basically display its reasoning next to its decision, visible on the main canvas as you can see in the video. The industry has a name for this. It's sold to enterprises as explainable AI or simply show you're working. But showing the reasoning doesn't really open the black box. That's what many people misunderstood. It just gives the black box a narrator. Both the multi-agent and the explainable AI solutions fixed the issues but created another unwanted consequences. First, we have actually covered this earlier. Leveraging multiple agents is going to be exponentially more expensive than a single one, especially when AI labs like Anthropic are aggressively redesigning their pricing. It's expected to spend 4, even 5 digits in US dollars monthly just on a single small project, which arguably is going to be the cost of hiring an engineer full-time. Second, the forced thinking out loud. When people see a confident, reasonable explanation attached to an automated decision, they are actually more likely to just accept it, including when it is wrong. It has a name: automation bias. The tendency to trust automated outputs over our own judgment, even when the evidence shows the opposite. So here is Deloitte's research for the UK Minister of Defense. They illustrate the risk with a simple driving analogy. Just imagine that you're driving and seeing a 30 miles per hour sign, but on your dashboard, you saw 60. So you accelerate, trusting the machine over your own eyes. Or you skip a turn that you know so well is the right one just because the sat-navs didn't prompt it. Either way, the system has quietly replaced your judgment instead of supporting it. Here's what's said in the report. In this situation, the use of AI has unwittingly impaired the operator's judgment rather than improving it. So in the first and second case, all assume that systems even knows what the situation is returning to, which brings us to the next demo. Engineered memory. Translation: LLMs start from zero every single time. A user with limited vision asks Netra to find their water bottle. The system scans the room and says, your water bottle is on the desk to the left of your silver laptop, approximately a meter away. The user walks to it and picks up the bottle. If you move the water bottle without telling the AI and comes back tomorrow and see what happens. The project brief calls the underlying system the memory palace, a persistent JSON store that builds a robust long-term spatial maps of a user's most important locations. However, that is precisely the problem with LLMs in many similar implementations. Yes, water bottle is still on the desk to the left of the laptop in the file. But what if someone loaded it in the dishwasher and forgot to put it back next to the laptop? The model will likely send the user confidently to an empty desk. The brief didn't mention how often they update the memory, but it is going to be a delicate balance between real-time and cost. This is statelessness, one of the serious negative characteristics of large language models. The model has no continuous thread of experience, so every session it wakes up as a stranger with notes. This demo is only a workaround that introduces a new failure mode on top of the original problem. still data that the model treats with the same confidence as fresh data because it has no mechanism to distinguish between them. At a demo scale like this, it's a file on a server, that's fine, but at the scale of any real deployment, it is a retention liability and the risk of contamination, the scope creep, and the leakage of what's in the memory. This is one of the reasons why Klarna's piloted AI customer service bots that could fully replace humans agents, but in the end still being rolled back to assistant only. Simply because the bot forgets you the second you switch from chats to a phone call, or if your connection drops. And once you see this pattern, it's hard for you to unsee it. The industry keeps selling these kind of workarounds as breakthroughs. What I'm going to teach you now is how to read the pitch backward so you can see through the sales line, understand the model's limits, and assess the cost of workaround for these limits. By the way, if what I'm about to show you give you a better bullshit detector on AI demos, pass it to someone else who needs it. How to read any tech pitch backward. You probably started this video expecting an analysis of why each demo did right to deserve the hackathon prize, I'm sorry, but I'd rather just rip the label off and show you the plumbing underneath. Learning to read things backward is going to help you evaluate AI's true value and its cost. But how? So let's start by understanding this. A solution always generates a new set of issues. For example, the railroad created rail engineers, and cloud created DevOps and FinOps. Why don't we use harness engineers / multi-agent orchestration, for example? Here's the backward reading. We're hiring harness engineers to build sophisticated multi-agent systems that orchestrate specialized AI workers. Again, it's just a sales pitch, but here's how you should read it backward. A single model loses the plot on anything longer than a certain number of tokens of real reasoning. So you split the job across X narrow agents, maybe even add one more to check their work, and hire a human, the harness engineer, whose entire role is to glue the crew together and keep it from drifting. Ignore what most pitches say. One harness engineer plus multiple agents replace a 5-person team, because the invoice by the end of the month was said otherwise. So a harness engineer in 2026 is a specialist hired at the price of $180,000 to $350,000. And underneath them sits a compute bill that scales exponentially. An X-agent crew with a critic reingest prior agent's output as context. So a single task runs 10 to 15 times the token of a one model call. On top of that, because Labs now builds agentic tool calls separately on top of seeds licenses. And then the hidden stack appears because you need databases for retrieval, orchestration services to route work, memory stores to preserve context, and monitoring tools to stop the whole thing from wandering off. Even the guardrails tell on the system. Iteration caps, timeouts, and cost ceilings are not just safety features. They are admissions that, left alone, an AI agent might keep spending without converging. Zoom out from the engineering. You also have the oversight tax. Carnegie Mellon and Stanford found that when humans supervise agents work closely, humans' productivity actually drops by about 20% compared with humans working alone. So the cost of operators doesn't really disappear as many might dream of. Instead, they get replaced by a more expensive team, a variable compute bill that grows with usage, a stack of net new infrastructure, and a human still sitting at the gate to sign the high-stakes calls. But more importantly, don't forget the bosses. This will likely scare away most of them, because this is an entire new way of operating a business that they have zero control over and zero expertise in. And none of these is something you intended to buy. With each one of the workaround is a tax on model's limit. Oh, by the way, for the paid subscribers on my newsletter, I will send you a few more AI terms with backward reading analysis. Sign up if you would also like to receive this exclusive piece. It will save you millions and headaches. I hope this one is insightful. If yes, Please do like and share this because this video is only possible with your engagement and support. Click here to watch more of my analysis.